Good evening, students. I am Rakesh here. Welcome you to my YouTube channel, and this is audiobook. Chapter 2 is matter around us pure. How do we judge whether milk, ghee, butter, salt, species, mineral, water, or juice that we buy from the market are pure? Have you ever noticed the word pure written on the packs of this consumable? For a common person, pure means having no adulteration, but for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of a single type of particle. In other words, a substance is a pure single form of matter. As we look around, we can see that most of matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soil, etc. all are mixtures. What is a mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that a dissolved sodium chloride can be separated from water by physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical process into its chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is same throughout. Soft drink and soil are not single pure substances. Whether the source of a pure substance may be, it will always have the same characteristics, properties. Therefore, we can say that a mixture contains more than one pure substance. Types of mixtures. Depending upon the nature of components that form a mixture, we can have different type of mixtures. Activity 2.1. Let us divide the class into group A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. Group B takes 50 ml of water and two spatula full of copper sulfate powder in a beaker. Group C and D can take different amount of copper sulfate and potassium permanganate or common salt sodium chloride and mix the given components to form a mixture. Report the observation on the uniformity in color and texture. Group A and B have obtained a mixture which has a uniform composition throughout. Such the mixtures are called homogeneous mixtures or solutions. Some other example of such mixtures are salt dissolved in water, sugar dissolved in water. Compare the color of the solution of two groups. Both the groups have obtained copper sulfate solution, but the intensity of color of solutions is different. This shows that a homogeneous mixtures can have a variable composition. Group C and D have obtained mixtures which contain physically distinct parts and have non-uniform compositions. Such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron filling, salt and sulfur, and oil and water are examples of heterogeneous mixtures. Activity 2.2. Let us again divide the class into four groups A, B, C, and D. Distribute the following samples of each group. Few crystals of copper to group A, one spatula full of copper sulfate to group B, chalk powder or wheat flour to group C, few drops of milk or ink to group D. Each group A should add the given sample in water and stir properly using a glass rod. Are the particles in mixture visible? Direct a beam of light from a torch through a beaker containing the mixture and observe it from the front. Was the path of the beam of light visible? Leave the mixtures undisturbed for a few minutes and set up the filtration apparatus in the meantime. Is the mixture stable or do the particles begin to settle after some time? Filter of mixture. Is there any residue on the filter paper? Discuss the results and form an opinion. Group A and B have got a solution. Group C has got suspension. Group D has got a colloidal solution. Now we shall learn about solutions, suspensions and colloidal solution in the following sections. Thank you for this time. Have a nice day.